Hello. Alright, so the purpose of this video is to show you how to find the maximum value of a parabola by completing the square. Okay, so in the first video, if you're kind of following along, basically what I showed you, right? So I gave you a parabola, and basically what we saw is if you see the sign in front here is positive, then the parabola is going to open upwards as you see here. And what I did was I actually plotted some values here. So for example, if you do negative 2 squared, negative 2 squared is negative 2 times negative 2, and that's going to be 4. If I plug in negative 1 here, negative 1 times negative 1 is going to be positive 1, and so forth. Okay, and you can see those values as you see there. So some of you may have learned this before, but basically, if I put a negative sign in front here, what's going to happen is instead of the parabola opening up upward, it's going to open downward. Okay, and I'll show you why that's the case here. So what we have is we're changing this around. So let's say, I know you guys can do this in your head already, but I might as well just show you if you don't believe me, rather than me just talking and stuff to you guys. So basically, if we just plug in x into here, we get negative times negative 2 squared. So that the way they get that is if you just follow PEMDAS. So negative 2 times negative 2 is going to be positive 4, and that's how you get your negative 4. So what's going to happen is this coordinate here will turn negative for the y's, and then as well as this one, if I put a 1 here, then this will turn negative 0 squared, right? So that's still going to be 0. If I put 1 squared, so 1 times 1 is 1, and then we have a negative in front, so that means it's going to be negative. And then if I plug in 2, so 2 times 2 is going to be 4, and then a negative comes after. And as you see, that basically shows why the parabola is open up downward instead. And basically, as you see here, by putting a negative sign in front, basically it's just flipping that parabola over the x-axis, as you can see. Okay. All right. So rather than me, actually wait. Before I switch the screen, I might as well just tell you a little bit more things about this parabola. So as you see, this the y value. If you look at this parabola, and if I just zoom out like forever and ever and ever out, and I go back in, as you can see, this parabola doesn't go anywhere past y equals 0. So it doesn't go above y equals 0 this time. The graph will only go below y equals 0. And this point here would represent the high point. And any high points that you see like this, that would be an example of a maximum value. Okay, so that's just me talking about it, but let's go ahead and put things into context. All right, so what I mentioned is basically, so if the y value, let's say you have y equals negative x squared, and basically your parabola is going to look something like this, right? So your parabola is going to look something like this, as you see. So if the sign in front is negative, so this here, you see the sign in front here, if it's negative, basically you're going to have a maximum value. Okay. And as we mentioned, and I showed you earlier, right? If you have a positive, right? Let's say it's this positive x squared. In other words, so the coefficient is positive. What I showed you in the first video, right? So it goes up like this, and then if the sign in front is positive, this would be a minimum value. Okay, so just keep that in mind. So that's just a recap of what I showed you earlier. So negative sign in front, it's going to be a max. If you have a positive coefficient in front, then it's going to be a minimum value. All right, so that's just a little bit of a review. And what I'm going to do is I'm going to show you an example. right. So an example for how this type of example will work. Right. So let's say I'm given, let's see, so let's say I'm given something like y equals negative x squared minus 8x plus 20. Okay, so let's say we want to complete this. Let's say we want to find the maximum value for this parabola. So we know it's going to be a maximum value just because, well, there's a negative coefficient in front here. So what we can do with this, I'm just going to write this whole thing out again. And this is why I was trying to stress this earlier. If you have a negative in front, so kind of what you're doing with the first example, but what you're going to do is if you have a negative in front here, you want to group these expressions like so. So if you're doing the opposite of the distributive property, if you pull out a negative from each of these terms here, what's going to happen is that this sign here is going to turn positive. So this sign here is going to turn positive. Okay, so now what we can do is our lovely completing the square process like I showed you in the other video. So we're going to create a bunch of blanks. So we have y plus something equals a negative times x squared plus, so this is a plus sign as you see here, plus 8x, and then plus something, and then we have a plus 20. Okay, I'm just going to continue really soon. I'm just going to stop the video for now, and I'll come right back. Hello. Okay, so continuing where we left off. So what we're doing for this particular example, if you're wondering, so now we created our blanks for trying to complete the square. So what we want to do is, again, we're trying to only look at what's in this expression here. And what we want to do is we only want to consider our b term. So our b term in this case is going to be 8. Okay. If you guys saw from the last video what we do when we complete the square, basically we take our b term divided by 2 and square it, and that's basically what goes in those blanks as you see there. Okay, so let's do that. So b divided by 2 squared, b is going to be 8, right? So basically b is going to be 8. Going to go ahead and do that. 8 divided by 2, so that's going to be 4 squared. This is 4 times 4, and 4 times 4 is 16. So what this implies is we're going to have a 16 here, but this one is going to be a little bit tricky, right? So basically what I showed you in the other video, right? Basically what you want to do is if you distribute this negative, if you just like do it just for fun, what you're going to realize is you're going to have an extra negative 16 here. So what this means is you think of the this process as like balancing a scale, right? If you have a negative 16 on one side, if you want to think about it, basically what this means is that you're going to have a negative 16 on this side. Does that make sense? Because you're distributing a negative, you have an extra negative 16 here. That means you have a negative 16 on this side. Okay. Now what you want to do is kind of clean this up. So this is y minus 16 equals, and then negative x squared plus 8x plus 16 plus 20. Okay. So next what we want to do is clean this up. What we can do is we can go ahead and factor this. So this, when you factor this, this becomes x plus 4 times x plus 4 plus 20, as you can see. And if you need me to, so basically what you're doing, you're finding two numbers that multiply 16 and add up to 8. Okay, that is also explained in another video if you need to look back at it. Okay, what we can do is we can take these factors here, and then we can write y minus 6 equals negative, and then we have x plus 4 squared plus 20. Okay. Some of you probably thinking, oh, I made a mistake here. You see that? So I forgot the 16. You see the 16 here? For some reason I put 6. Good thing I caught it now. Good thing I caught it now. All right, so what we want to do is we want to get y by itself. So in order to get y by itself, we need to add 16 to both sides here. And then what we're going to get, sorry, I'm running out of room here, so I'll just write it here. So this is basically what it's going to be. 20 plus 16 is going to be 36. So my bad, I'm going to write that there. So basically this is going to be, this cancels. So we get y equals, and we have negative x plus 4 squared plus 36, right? So basically this is how this expression will transform into this expression by completing the square. Okay, so what we want to do is we have to next identify the maximum value. So we have to identify the maximum value of this function. So what we saw here is that just by starting with this expression alone, we don't know any properties yet about this parabola until we actually complete the square. And then what we can see is, just like in the other video, right? Basically, if you want to find a minimum value, you'd have to look at the last coefficient. Same idea goes when you're trying to find the maximum value. So what this means, basically, you just take the last number, and the maximum value is basically going to be the value y equals 36. Okay. Now let's go ahead and graph both of these just to make sure that we did it correctly. Right? So I'm just going to go ahead and clear some of these things here. So let's say I just graph y equals negative x squared minus 8x plus 20. Yep. And then let's say we want to graph y equals negative x plus 4 squared plus 36. There we go. As you see, the red curve goes right over the black curve. So what I want to show you is if I just get rid of this red here. So if you, again, what I said was, if you look just at this function, if you look just at this function, you can't really tell anything about that that quadratic expression until you complete the square. Then you can see that the maximum value here, the maximum y value, it doesn't go anywhere past 36, if you're wondering. And that is exactly what we have here. Okay. I'm going to show you two more examples. Okay. Right. Hello. All right. So I'm basically just going to continue where we left off. All right. So let's say we have something like y equals negative 3x squared plus 30x minus 60. Okay. So I can see for some of you it might be intimidating, like, oh, let's just pull out a negative 3 from each of these terms here. But if you want to do this process for completing the square, just look at the first two terms here. Look at the first two terms. Don't worry about that last constant, whatever it is. Only look at the first two terms, okay? So let's go ahead and do this. As we see here, let's go ahead and put parentheses around here. This is going to be negative 3x squared plus 30x minus 60. Okay, next what we're going to do, now what we have is we look at only this term and this term and see if there's a common factor that we can pull out. So in this case, there is a common factor that we can pull out. We can pull out a negative 3. So then we have x squared, and 30x divided by negative 3 is going to be negative 10x. So it's going to look something like this, right? Next, what we're going to do is we're going to create our blanks for completing the square. So we have y plus something equals negative 3 times x squared minus 10x plus something minus 60. Okay, what we want to do is look at this expression, identify what b is. If you guys kind of see what we're getting at, b is going to be negative 10. So b is negative 10 right here. Basically, if you guys have seen what we did in the other videos, take your b term. Your b term is negative 10 divided by 2, square that quantity. So negative 10 divided by 2 is negative 5 squared. So negative 5 times negative 5. and that should give you positive 25. Okay, so what this implies is that we know that 25 is going to go here. Now, this part is interesting. So when you go ahead and distribute this here, what you're going to realize is you have an extra negative 3 times 25 on the right hand side, which is negative 75. So if you guys have been kind of following along what I've been showing you in the other videos, basically what this implies is we're going to have an extra negative 75 on this side. So basically negative 3 times 25. Okay, next what we're going to do is we're going to go ahead and simplify this. So we have y minus 75 equals negative 3. Again, take this expression here, and what you want to do is you want to try factor it. So if you factor it, you're finding two numbers that multiply to 25 and add to negative 10. Do this correctly, you're going to get x minus 5 times x minus 5 minus 60. Okay. Next, what we can do is we can group these factors together. So y minus 75 equals negative 3 times x minus 5 squared minus 60. Okay. Next, what we want to do is we want to go ahead and get y by itself. So to get y by itself, we're going to add 75 on both sides. This will cancel. We get y equals negative 3 times x minus 5 squared plus 15. So this, if you're wondering, would be how we would transform this quadratic expression and turn it into something like this. Yeah. Okay. So what we want to do, second part, is we want to be able to identify the maximum value. So maximum value again. Basically, what we're doing in order to identify that is we're looking at the last number that you see here. So the maximum value, if you're wondering, so maximum value is going to be at y equals 15. Y equals 15. All right. So just to give you guys some sort of context, let's go ahead and graph these just for fun. So we have negative 3x squared plus 30x minus 60. And if I graph the other one, we have negative 3 times x minus 5 squared plus 15. Good. So as you see, if I toggle this here, we got the exact same expression. Basically what we see is the maximum value, the maximum y value it goes to is 15. Okay. So that is basically how you would do that. Okay. So I'm going to clear the screen. I'm going to show you one more example. One more example here. Let's say I have something like y equals, so negative 4x squared minus 16x plus 23. Okay, same idea. What we want to do, if we rewrite this right here, we want to put parentheses around these terms. Put parentheses around these terms. And what we want to do is pull out any common factors. What I see is we can pull out a negative 4. So if we pull out a negative 4, this becomes x squared and then plus 4x. So plus 23. Okay. So next what we want to do when we're completing the square, again what we're going to do, we need to figure out what goes in those blanks, as you can see. Okay. Identify what's in here, what your b term is. So what we have is b is going to equal 4, right? So basically when you go ahead and do this, basically you just take 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 2 times 2, and that's 4. So that means 4 goes here. And then think about what you are doing when you're distributing that negative 4 back in. What you're going to have is here you have a negative 4 times 4 on the right hand side. So what that means is you're going to have, again, you're going to have a negative 4 times 4 on this side, or in other words, basically we have a negative 16. Okay, now let's go ahead and clean this up. Y minus 16 equals negative 4. Factor this expression that you see here. So if you factor this, find two numbers that multiply to 4 and add up to 4. Do that correctly, get x plus 2 times x plus 2 plus 23. We can clean this up even further. So we can group these. Y minus 16 equals negative 4 times x plus 2 squared plus 23. Okay. Next, get y by itself. In order to get y by itself, we're going to add 16 to both sides. 16's cancel out here. We get y equals negative 4 times x plus 2 squared plus 39. All right, cool. So that's how you transform this expression on top. Get something on the bottom here. Now let's go ahead and identify our maximum value. So in order to identify our maximum value, again, all we do is just look at this number in front here. So maximum value is going to be y equals 39. All right, let's go ahead and graph this on Desmos to make sure that we did this correctly. So we have y equals negative 4x squared minus 16x plus 23. And we also have y equals negative 4 times x plus 2 squared plus 39. And as you see, if I just toggle this red and black here, basically that means we did this correctly. And as you see here, this means the maximum y value is going to be 39. It doesn't go anywhere past 39. All right, so that will hopefully help you with that part of the Google form. All right, so let me know if you have any questions. Okay, bye. Hello. All right, so what I figured is I might as well summarize some of the things that we went over. So let's say I asked you to identify whether you have a minimum or maximum value just by inspection. Okay, so easiest way to do this is just look at the sign in front here. If the leading coefficient is positive, right? So leading coefficient is positive. Basically what that implies is it's going to look like this, right? So what we have is this is going to be a parabola that opens upwards. So that means it's going to have a minimum value, right? So this means we're going to have a minimum value. And then we look at this number at the end. So we have y equals negative 23. Okay, for this one, look at the sign in front. If you look at the sign in front, basically this is a parabola that opens downward, as you can see. And again, what you want to do, look at the last number. So basically, this is an example of reaching a maximum value, right? So we have a maximum value, and that's going to be at y equals 36, as you see right here. Okay, so what we have here for this one, again, look at the sign in front. The sign in front is negative, so what this implies is the parabola is going to look like this. Okay, so since the parabola is going to look like that, this means we're going to have a maximum value. Okay. So we're going to have a maximum value, and it's going to be at this y value. So y equals negative 7. Okay. And then we have this one here. So we look at the sign in front. Sign is positive. Since the sign is positive, basically what we have is we're going to have something like this, right? So what this implies is we're going to have a minimum value, and that minimum value is basically found by just looking at the looking at the number in front. So we get y equals 5. Yep. So that is basically how you identify your min and max y values. Now the interesting thing about this, so you see these here, we have maximum value here and here. So maximum values can be negative or positive, as well as minimum values. So minimum values, as you see here, minimum values can be negative or positive as well. Okay. Yeah. And of course, what you can do is you can graph these on Desmos if you don't believe me. All right. And that's basically what I want to show you. All right. Let me know if you have any questions, anything, and I'll help you out if you have any other questions. Okay. Thanks.